Be the first term ever where I don't do a whole lecture on mute. Wow. I'm growing, guys. All right. I changed the assignment due dates by 1 day, so nothing crazy. But the assignments for 8.4 and 8.5, I made them do the 16th instead of the 15th. Because I have a department meeting. You guys don't care why. I'm unavailable on Monday. Usually it takes all day, so it's kind of annoying. But so I'm not available on Monday, but I will be in my office Tuesday and Wednesday, and of course on Thursday. But I'll have to run home between kind of the day and our exam, which is in the evening. And so, but I am available Tuesday, Wednesday, and Thursday in my office, C104, in case you haven't been. Huh? Nice. Hey, look at us. Might be the most people we've had in a while. Finish strong. All right. Let's see here. What else? So I made them do the 16th just because I'm not available on Monday. Whatever. Okay. We finished all the new material last day. And all I have kind of prepared for you today is I should do it like a cooking show. And what I've prepared for you today is an overview of the final exam. I hope you enjoy. So let's talk final exam. Overview. As promised, I will be taking questions from test 1 and test 2 exclusively, and probability. Sprinkle in some probability. So I'm really trying to make you focus on what's important. On test number 1, or from test number 1, we started with linear equations, right? How do you find the equation of a straight line? How do you find the slope? How do you find the intercept? All that kind of fun stuff. And I'm going to say approximate marks here. Approximately 10 marks from linear equations. As opposed to from test 1, I've kind of taken roughly half the marks from each of the test sections. And so then we moved on to linear programming. Which I'm going to give you a little bit more information and just make it out of 5, right? Linear programming was that maximization problem, I think it was in the test scenario, right? And so just make sure you study that one. I'll make you find the intersections, but I might give you the equations of the lines, but you had to do that on the test, so that'll save you a little bit of work. And so it'll be like half of the test question, essentially, the later half. And then we did logic. From logic, you guys liked logic.
Feels all right.
Yeah, everyone's like, well, no, I was just gonna do 5. Now, these are all up for discussion. I'm flexible. I have not put together the final exam yet. I know, bad. But means there's some room for negotiating.
Can we move those 5 from logic and place them into linear programming?
We could. I'm not sure the rest of the group feels the same.
I am addicted.
Hey, when I called you over today and asked you, hey, do you want to make the final exam together, or do you want me to just tell you what's on it? You said, just tell me what's on it.
True.
Huh.
But I've changed my mind.
I think 5 and 5 is good. We do have to do logic on the final exam, so 5's nice. That's nice. I know. I should have a choice if you want to show off your linear programming skills. It's a huge bonus question. Then from test 2, there were 2 topics, financial math. That's a heavy hitter. Right. And so I'm thinking roughly 15 marks. It's an important topic and everyone did pretty well on it. And so that's something that I take into account too. I'm kind of like, well, you know, if you guys are all generally strong in a topic, then I'm happy to kind of weight that a little bit more. Sets, I think sets were pretty good. Set theory, I've got roughly 10. Now, this is going to include combinations, which was the 2 bonus questions on test 2, but they'll just be regular questions now, right? It's only because we had just introduced it, so it didn't feel fair. But this includes combinations. Then from probability, which is the only section that we haven't been tested on yet, I'm thinking 4 marks from each section. I know, here we go. 8.1, which was where we started with, what did we, sample spaces, right? 8.1 is sample spaces. Roughly 4 marks there. 8.2, I should pull it up because I do not remember. 8.2 is mutually exclusive and the addition rule. Oops. Again, roughly 4 marks. 8.3 is the tree diagrams. So we use the tree diagrams to find probabilities. Tree diagrams and combinations, right? Where we used instead of the tree, because if the tree gets too big, you can still do it, but sometimes it's just out of hand. And so then you can use the combinations equations instead. And so I've got roughly 4 marks there. And generally, any question that requires kind of more than a quick little calculation, I would do 2 marks for, right? And then mark on a 2-mark scale. And so 4 marks tends to be 2 questions. Tends to be. Now, if it's just kind of a quick answer, right, then it's only 1 mark, but just so you have an idea of, you know, what to expect. Okay, 8.4. This is where I'm kind of toying with maybe 6 marks. 8.4 is on conditional probabilities. Right? Probability of E given F, which we worked with last day. And so I'll say for or.
For the probability questions, are you only taking those at level 13?
Yeah. I'll be even nicer and only take them out of the questions that I did and posted solutions to.
Wow,
Is that nicer or is that meaner?
No, I like that.
that's very nice.
Yeah.
I'm like, oh, stop. I've got a hair in my eye, I think. Oh well. Yeah, so I'm leaning that way because then you can practice those and you've got my solutions and you know exactly what to expect. And then finally, 8.5 is on independent events. Or and I was gonna do 4 marks. Only from I do the odd exercises in the homework or in the textbook. Right, the ones that I've posted the solutions to. Yeah,
And, right?
no card ones. And I should say and no card questions. Really narrowing it down a little bit. But in a final exam scenario, I don't want you to have to think about, oh, okay, well, what does a full house mean in a hand of cards? That's like if you're sitting down and you can kind of think about it and you know, talk it out. That's not a final exam scenario, right? So no card questions. Good, thank you. And now you've got it in writing.
What equation?
I guess, yeah, so for the formula sheets, I'll give you all the same formula sheets that you have been getting as well as the ones for the probability, which I'm just thinking now I should have probably put together. Well, win some, you lose some. There's time. So I'll post the probability formulas, but all the other formula sheets that you've gotten from the tests, I'll just keep them the same. And give them to you, which is a lot of formulas. You don't need, but I felt like that was too telling. It's nice to have a full formula sheet. So what is the total here? I didn't write it down, but 20, 30, 45 plus 65 or 67, depending on what I decide there. From there, which means if you only did the test 1, test 2 stuff, you could still pass. Wow. That is crazy.
And get them all right.
Yeah, I mean, yeah. But it's there. It's within reach. Do it. Okay. Anything else? Any other questions? That's all I had to say. Yeah, I guess. Well, if there are questions that you want to work through, you can do that.
Can you go with the table?
Yes. Oof. Please stay on the line. I'm like, Practice test. I think it's just easier if I just jot it down. Or before I do that, any questions about the final exam or kind of what's expected or what to expect? Okay. Cool. No, I'm completely, my creativity is hampered when I use the textbook questions.
Should we get bonus question? And then get 1 mark and just make a whole story. Just-
A whole story about manatees.
Or meerkats, or both.
Or moles.
Oh, right.
So then I can say, holy moly, what a good term.
And then just make it a birthday party.
Wow,
A
that's
manatee-
pretty good.
A group of manatees, meerkats, and moles all have a birthday party.
You're coming for my job.
What was my favorite song as a child? Not the number 5.
Sadly, I think I was a young adult.
I don't know. My apologies. I don't know the number 5.
I don't know either. I know I've looked it up, but
That's a
sure is. P or Q and not Q, then P. 2000. Just a young sprite. And we want to know if it's a tautology, a contradiction, or neither. But let's do the truth table first. A tautology means that the final statement is all ones. Contradiction means the final statement is all zeros. And neither means it's neither of those. Now the tricky part, and if I was to use this on the final exam, first thing you'd want to do, I'm like, no, you can handle it. You can handle it. Is remember the order of operations for the logical compounding, which means that, whoops, these would be done first. So it goes negations first, then ands, then ors, and then the conditional, which means you'd have to do all those first. And then the if then. So I've got P and Q are my statements, and then I've got Q and P. So I only have 2, right? And so I set up my truth table like this. 0, 0, 1, 1, 0, 1, 0, 1. And then I'm slowly going to build out to this final statement. Okay. And like I said, I like to do the negations first. Okay. So not Q. Well, a 0 turns into a 1 and a 1 turns into a 0. Okay. Next, I'm going to do P or Q. Now, P or Q is when either one of these or both are ones, we put a 1. And so we've got P or Q. 0, 1, 1, 1. Now what I do when I mark these is if you make a mistake, I follow through with that mistake, because otherwise how else would you know to change it? That would be extra weird if you knew to change it halfway through. So so whatever you tell me it is, I follow through with that. So now we've got P or Q here. We've got the not Q here. And now I want to do the and of both of them. Well, those are only going to be ones if they're both ones, right? The first one has to be 1 and the second one has to be a 1. So I can build P or Q and not Q. 1 and 0 is a 0, 0 and 1 is a 0, 1 and 1 is a 1, and 0 and 1 is a 0. And finally, P or Q and not Q as one thing, right? And if you want, if you prefer, you could call this something like A, right? And then just write if A, then P. You don't have to write those all out. You can give them names. Because that's just going from one column. Now, the only time that this is false is if you go from a 1 to a 0. Right? Otherwise, they're always true. And so let's see here. I'm going from A to P. Now, it might be nice to jot down what P is here, because then you can look at them and you don't have to kind of jump around so much, right? So it might be nice to just copy down P here, because then you can look this way, right? From A, so if A, then P, then 0 to 0, that's true. 0 to 0 is true again. 1 to 1 is true. And 0 to 1 is true. So it doesn't matter what combination of P and Q you have, right? That's always going to be true. So it's a tautology. Since the statement is always true, it is a tautology. If it was always false, it would be a contradiction. Most of the time, though, we have neither, right? Where there's kind of a jumble. Any other questions? And more importantly, was the party in the courtyard really short or something?
Short?
It was like, yeah, wasn't it? Joya came in, she told me, she's like, hey, there's a bunch of stuff going on in the courtyard. And then I went out to go check it out and they were already packed up.
What time?
I went out at 2.
They were there since like 10.
Oh, so my bad.
No, like I was in the library while they're setting up and we had music class. So in the library, you could get Like, we were in
Root.
the corner right there anyway, so you can hear like a skateboard as it is.
But that's not really final exam related, I guess. Any other questions?
So I'm not.
That's the game. Gotta get all the free food.
That's all I want. That's all I ask for. Being in college, I want free food. That's it.
You've already kind of paid for it.
Exactly.
Any other questions you want to go through? You're feeling like,
Maybe one of the ones from the homework for 8. Wait, the last one.
mhm.
Oh, yeah.
We also had free food while doing that. But I was not sure if we were going.
8.5. Do you remember which one?
Oh,
Oh,
the one where it's like you have the and or and then you change it to you have or and then you gotta change it to and or the opposite way around. That's for or if it's equal to like the one bottom. then some-
so yeah, so from 8.5, you want to do you mean like the probability of A or B is the probability of A plus the probability of B minus the probability of A and B? Do you mean like that one?
Probably. That works.
And if A and B are independent, which is the topic of that section, so I suspect, then we know that the probability of A and B, and B is the probability of A times the probability of B. And then I think some of them were using that formula. And you were able to find,
We were timesing everything.
I just told them to multiply everything.
Yeah.
And then I'd get an answer and I'd be like, that works.
Did you get it? Yeah.
but you don't remember which one?
I don't remember my thought process,
That's fair.
but numbers align in some cases. And then I was like, okay, these are independent, these aren't. And called it good.
Sold. How about this one? Something like this, maybe. Hopefully this one pans out. If the probability of E is 0.6 and the probability of F is 0.2 and E and F are independent, find the probability of E or F. Did I nail it or what? The probability of E or F is the probability of E plus the probability of F minus the probability of E and F. And we're given that the probability of E is 0.6 and the probability of F is 0.2 and the probability of E and F, because we're told that they are independent,
Yeah.
then you can times them. But everyone loves jumping to that one, even when they're not independent, so you want to be really careful. But 0.6 times 0.2, is that 0.12 or? Nice. So I get 0.8 minus 0.12, 0.6, oh, 0.68.
See, I did
Oh,
that.
I do have it here.
Really happen.
This would definitely be a 2-mark question, right? Just in terms of kind of figuring out how many marks there would be. I would say this warrants kind of 1 mark, and then this is another.
Thank you. That makes sense.
Nice. Any other doozies? Or not doozies, maybe, but
We do 20.
got it.
So do random ones from this homework. So
Eight 8.5. Number 20. At a college, 54% of all students are female. 60% of all students receive financial aid. 60% of female students receive financial aid. Let the event A be that a student receives financial aid, and F that the student is female. Are the events A and F independent? Remember how you need to, what you need to do to prove that? If so, A and F are independent if the probability of A and F is the probability of A times the probability of F. Right. And so here, what are the probabilities that we've been given? The probability of a female is 0.54. The probability of A is 0.6. Now the tricky part is, what's that last one? 60% of female students receive financial aid. That's going to be the probability of financial aid given that it's a female, right? So knowing that it's a female of the females, then 60% of those females receive financial aid. And so the probability of A given F is 0.6. So we can use these. Probability of A and F is, well, actually, we don't even need to use that formula. Why? Because knowing that it's a female doesn't change the probability of financial aid. Right? And so that's why they're independent. We can still do it with this way, but I'll show you both. If the probability of A given F is equal to the probability of A, which it is. Or the long way. You'll still get there. We want to show this, but we also have the probability of A given F, which we know is the probability of A and F divided by the probability of F, which I could use to solve for the probability of A and F. So then the probability of A and F is the probability of A given F times the probability of F. Right? This is the long way. So we already answered if they're independent just by remembering the fact that if the conditional probability doesn't care about what we've been given, then they are independent. But this way is always going to work.
Would you prefer that then?
Doesn't matter to me.
Doesn't matter?
Same marks. And so this long way will always work. Right, but either way, it's fine. So the probability of A and F is A given F 0.6 times 0.54. 0.324. And that's gonna go in here. Or we can say the probability of A and F, does it equal the probability of A times the probability of F? Now seeing that, again, the probability of A given F is 0.6 and the probability of A is 0.6, I suspect they are, right? But that was the argument we already made. 0.324, does it equal 0.6 times 0.54? It does. Therefore, they're independent. So a couple of different ways that you could have gotten the same result. Long way or the short way. And then find the probability of A and F. Well, we already did 0.324. I'll say B, the probability of A and F. Because we already found it. Nice. I feel like we should zip through and find the formulas. But I'll post the formulas. And then if there's one that you're like, hey, I think we should have this one, then just let me know. But before I print it, or I'll just put it on the board or something. Any others? Taking requests. Mambo number 5. Duh, 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 duh.
Or the fish song.
We looked up. the
Fish,
song.
that's, oh, did
I
you?
read
The
the
lyrics.
lyrics. The lyrics are funny.
Okay.
Did you know they can't drink cappuccinos?
No. I don't remember that part.
They don't have that jet.
You know what, that tracks actually, yeah, that, okay.
Yeah, still my joke. Right?
I only had to listen to it multiple times.
Any other questions? Then I guess with that, I want to thank you for this term and I release you.
No, anything.
And we're that much closer to summer. Let's stop this here.